The scene here is San Francisco Harbor. The ship has just arrived from Baltimore through the Panama Canal, bringing in its cargo the 6 reels of submarine telephone cable that we see being transferred to a waiting barge. The end of the long journey from the eastern factory is near, where the final resting place of these cable circuits is to be the floor of San Francisco Bay. In fact, these are the actual circuits that were planned to serve the artificial island that was made to rise from these historic waters as a home for the Golden Gate International Exposition. And after serving the crowds thronging this appealing panorama of foreign and domestic attractions, these same circuits will be part of a great new cable artery. This artery will join the others already winding beneath the surface of the bay to bring the voice of America to this busy port on our western shore. There's an interesting engineering story in this sequence of pictures, but I see in them another and a special significance, and that is the extraordinary skill and technique that is mobilized in this modern day to combat a small but deadly peril to such circuits as these: a single drop of water. Yes, it is of vital importance to prevent the entry of a single drop, for if one drop can enter, so can another, and another, and another, until the electrical transmission of speech is impossible. So underwater circuits must be provided by the cable makers with unusual protection both against leakage and against accident. The camera's lens gives us a close look at this protection as it pictures 2 cable lengths being spliced together. The splicing job itself is no small task. The engineers anticipated the needs of the coming years and called for 1,056 wires, each wire separately insulated. There's a boiling out process with petrolatum to remove every trace of moisture, and then the lead sleeve is pulled over the splice, and there's some mighty hot lead to handle as the sleeve is made part of the cable's smooth and pliable metal coat. This looks like a workmanlike job, but these cable men aren't yet satisfied that the splice is airtight. We're going to conduct a most important testing investigation. A hole is made in the lead. Nitrogen gas at 20 pounds pressure per square inch is forced through the hole to surround the wires just spliced. And then an extremely unromantic substance comes into use: plain, everyday soap suds. But the soap suds are most effective here, for if gas is escaping, there will be soap bubbles to mark the spot. The job we're watching is pronounced good. The double armoring is the vitally essential precaution. Nothing on the bottom, like a dragging anchor, for example, can scrape or break the sheathing of the circuits and let the water in. And since the corrosive effect of salt water on metal is a peril to be guarded against, the armor gets 2 final overcoats of tar-treated jute to make corrosion very, very slow. Finally, about 2 miles of armored cable is coiled on the big drum, ready for its underwater resting place on the floor of the bay. One of the piers of the Bay Bridge that stretches more than 8 miles over land and water to link San Francisco and Oakland is the midway point for uniting 2 long underwater sections. A diver first goes overboard to make sure that all goes well in placing the pier end of the cable. And when he's back on board with his report, there's nothing more to do except head for the terminal on the distant shore while the cable disappears in the churning waters of the barge's wake. So look out, Father Neptune, down there in your underwater kingdom. Here come 1,056 wires. There's no use trying to get them wet, for I don't think it can be done.